Right now we're going to look at a hypothesis testing question. This one's going to give us a little more work because in this case we will only be given sample data, meaning the raw data. So let's take a look. So suppose the question is, does the average person own more than 3 hats? Let's say you survey 15 people who respond with these numbers right here. So what can you conclude and at what confidence? All right, so this is a hypothesis test. We're being asked to draw a conclusion. So we have to go into our 5 steps. So step 1 is write down our given information and write down the claims. So the claim, well, the very first thing is the question, does the average person own more than 3 hats? So that claim is mu greater than 3, and it's a greater than statement, so that's the alternate hypothesis. So, the alternate hypothesis is mu greater than 3. And now we have to write down the null hypothesis. So, again, there's 2 different ways to write this down. The standard way to write it down is mu equals 3. Some people prefer writing the opposite of the greater than, so they'll put in a less than there. You can do it either way. So these are the claims. Now what's the given information? So the given information, so we know that we're surveying 15 people, so we know sample size n equals 15. Now normally we'd also be given the sample mean. We don't have that. We just have a bunch of sample data. We'd also be given some kind of standard deviation. We're not given that. Again, all we're given is the raw data from the sample. So what do we have to do? We must calculate the sample mean x bar and the sample standard deviation s. So we could do that by hand. We know how to we've got 15 numbers. We know how to calculate a mean, and then we also know how to calculate a sample standard deviation. Doing it by hand, well, that sounds like a lot of work, so we're going to use technology. Now, there's a couple different pieces of technology you can use. I'm going to demonstrate the way to do this using a spreadsheet. So the first thing to do is to first enter your data. Let's say I got a 2, 5, 0, 8, 3, 3, 4, 3, 9, 1, 2, 2, 4, 12, and 5. Okay, so now we need to know the command to find a mean and a standard deviation. So the command for that is equals average. And then you type open parenthesis. And now you highlight your data and then you just hit enter. So again, just looking up in the formula bar over here, you can see what was typed in. So you can just type in equals average open parenthesis and then highlight your data. And that tells you the mean. So that's our x bar. Our x bar is 4.2. Now we need the standard deviation. So the command for that is equals stdev open parenthesis. And now just highlight your data and then hit enter. And there is your standard deviation s. Okay. So now we're going to write these things down. So for the x bar, it's 4.2, and for s, I always say if you round to 4 places, you're okay. So 3.2338. And I'm going to say in a spreadsheet, you can use Excel if you have it. I just used LibreOffice. Or you can use Google Sheets, which is available for free online. Okay. So now we've got our basic information, and this at this point more or less reduces it to the previous sort of problem that we've seen, but let's just keep going through it. So now step 2 is describe the distribution. So describing the distribution, what's the shape? Well, we noticed that we were not given the population standard deviation sigma. And also we have a small sample size, and we're not told anything about the population itself. So therefore, we're going to say the shape is a t-distribution. It's not normal. And then we're going to say the mean. So the mean is the mu of the x bar, and mu for x bar, we're going to use the value from the claim, and that value is 3. Next, we need the standard deviation of our distribution. So this is going to be S for x bar. So the standard deviation of the distribution is going to be the S that we calculated, which is the sample standard deviation, but divided by the square root of n, which in this case is rad 15. And if you type that in and work it out and round it to 4 decimal places, you get 0.8350. Okay. So that's step 2. Step 3 is draw the picture. So the picture is a t-distribution, which is just a hump, just like a normal distribution. And we know that now it's got t values with 0 in the middle. And then our x bar values, well, we're using the mean, which is 3 that goes in the middle. And then we've got the value from the data. The x bar from the data was 4.2. And then our hypothesis test, this was a greater than alternate claim. So we mark off 4.2 and it's greater than, which is a right tail. So we shade the right tail. There's the picture. Next we do our calculations. So calculations, notice that we are starting with, in a sense, an x bar value, and we need to get a confidence level, which is going to come from the area. Middle step is to find the t-score. So let's calculate. So the t-score equals x bar minus mu for x bar over s for x bar. So our x bar was 4.2. The mean from the claim was 3. And the standard deviation of our distribution, we calculated it, was 0.8350. Okay, so calculate that, and you get 1.44. So there's your t-score. So that, right away, is something that we can fill in on the picture. The t-score right there is 1.44. Okay, next we need to find the areas. So to do that, give me 1 sec and we'll pull up the stat disk. There we go. Okay, so here's stat disk, and we need the, so first we're going to go into probability distributions, and we know that we're using, oops, good, so you can see, and we're using the t distribution. And so first of all, we need degrees of freedom. Well, we know that n equals 15, so the degrees of freedom will be n minus 1, so that's 14. And then we need to input our t value. So to recall that, that was 1.44. And then just click Evaluate. And there you go. So again, noticing from the picture, we're going to need the area to the left and the area to the right. So the area to the left was, so this is telling us this number, and I'll just round it to 4 decimal places, so 0.9141. and then similarly for the area to the right. So make a spot for it. Okay, so this area was 0.9141, and then the area to the right, we can also read that off, is 0.0859. And those are our calculations. So finally, step 5, we make our conclusion. So what's the conclusion? We are 0.9141, which is 91.41% confident that, so we express confidence in the alternate hypothesis. So that's mu is greater than 3, meaning the average person owns more than 3 hats. Okay. And we can also note that the p-value equals 0.0859. So now, follow-up questions. At 10% significance, what can we conclude? So notice that 10% significance is like 90% confidence, and we do have that much. So we say yes. At 10% significance, which we can say is also 90% confidence, we reject HO and accept HA, or H1 as you like. And then also at 5% significance, what can we conclude? So in this case, 5% significance is like 95% confidence. Do we have it? No, we do not. We don't have enough confidence, or we can look at the p-value and say the p-value isn't good enough. Either way. So we say no, we don't have it, therefore, at 5% significance, which is the same as 95% confidence, we do not reject HO, we do not accept HA. And so that is, and now we're done. And again, notice that doing the calculation, which gives you a confidence level and a p-value, you can then answer any question you like. What can you conclude at 10% significance, 5% significance, 2% significance? You can answer any type of question with the calculation that you've done. So this was how to do a hypothesis test question if you are only given raw data from a sample. And we're using technology to do it.